test. Just making sure everything's good to go. How's everyone doing? We are going live today. It's going to be a short one. Just kind of wanted to give you a quick preview of what we're doing. Systems of linear equations. We're going to start off with some elimination. Then we're going to go ahead and do some substitution. And we're going to do, it looks like 3 word problems. Very basic. That's going to be the entire live. However, if you have any questions, please feel free to send them to theveganmathguy.com. Members, you're guaranteed to get your problem solved. I'll probably solve anything that you send me throughout the weekend on Monday morning. But this is Systems of Linear Equations. Please feel free to subscribe to my YouTube channel. Follow me on Instagram and TikTok. And I think we are ready to get started. Don't think we have much anything else to do. But again, comment or let me know anything that you want to review. All right, guys, let's go to the very first slide. Looks like we just have a bunch of systems of equations. And this particular, the directions here were to use elimination. So let me just go ahead and write the first problem down. Looks a little blurry there. This was sent to us or to me by a member for me to solve. And that's what we're doing now. Okay, so we're using the elimination. The goal for elimination is to make sure that we have one of the variables having the same value but opposite signs. Now, I can already tell that I want to eliminate the x's because one of them is a -2, the other one is also a -2. But you know what I can go ahead and do is multiply the bottom equation by -1. And this is what's going to happen. First equation becomes -2x minus 5y is equal to 3. And the bottom, now we're going to multiply everything by -1. So what we're going to have is 2x minus 2y is equal to -10. That's elimination. Look at that. I'm going to highlight that again, -2x, and we have the 2x. So now we can go ahead and combine like terms. So we're going to go ahead and combine these things vertically. Now what happens to your x's? -2x plus 2x cancels out. And that's the goal. That's exactly what we wanted. The y's, -5y minus 2y. That's -7y. And on the right side, 3 plus -10, that is going to be -7. Now I can go ahead and divide the -7 to both sides so that I get that y is equal to -1. That's exactly what we want, okay? We want to eliminate one of the variables and then solve for the other. So now that we have y is equal to -1, in order to find the value of x, I can go ahead and plug in the y into any one of the equations that I was given. I'm just going to plug it into the first equation. That's the first equation that we had there. Okay, so we're going to have -2x minus 5 times, let me go ahead and substitute that in, -1 is equal to 3. Let's simplify. -2x, we have 2 negatives there, so that's going to become a +5, so plus 5 is equal to 3. And now let's solve for x. Whoops, I'm not subtracting by 2. I'm going to subtract both sides by 5. And we get -2x is equal to -2. Divide both sides by -2. And x is equal to 1. Awesome. Now, typically, we can just say x is equal to 1, y is equal to -1, and we can call it a day. Usually, a lot of teachers are going to want you to write your answer as a coordinate because that's the idea. These systems are intersecting at a specific point. So that's exactly what we're going to do. All right. So we're going to go ahead and write our equation or our answer as y, comma, -1. All right. Let's go to the second problem. Let's erase that. -6x plus 3y is equal to 9. -8x minus 7y is equal to 23. Ooh, I like this problem already. Why do we like this problem? Because we have to really be a little creative on how we're going to solve and eliminate one of the variables, okay? Because we can't just multiply, the top by something and the bottom by something. separately, it looks like we're going to have to multiply something to both equations. In this case, I'm just going to make the goal to eliminate the y's. You know, I already see one's a positive, the other's a negative. So in order to have the same value, let me multiply the top equation by 7 and the bottom equation by -3. And what is that going to give us? Let's figure it out. -42x plus 21y is equal to 63. Now, how did I get that? I took the 7 and I multiplied that to every single value in the first equation. And that's exactly what we're going to do with the second equation, the one at the bottom. I am multiplying the -3 into everything. And now that's going to give us 24x plus 21y. Looks like I screwed up there. I should have just multiplied the bottom equation by +3. So let me just go ahead and erase that now. You can kind of already see why I wanted -21 and why I made that mistake. You want a +21y and then you want a -21y on the bottom. So let's go ahead and redo that now and multiply the bottom equation by 3, and that's going to give us -24x minus 21y is equal to 69. Okay. Wow, do I have the same? Yeah, it looks everything's looking good. And again, let's go ahead and combine the like terms. So we're going to go ahead and add these vertically. The x's would become -66. X, the y's cancel out. That's exactly what we want. And then we're going to go ahead and add 63 plus 69. It is equal to 132. And to get the value of x, let's go ahead and divide both sides by -66. And I get x is equal to 2. Awesome. Okay, again, we have the value of x. Let's go ahead and find the value of y. So we're going to go ahead and plug that in. The x is equal to 2 to any one of the equations. So I'm actually going to plug it into, I'm just going to do the first equation. So let me just rewrite that. -6x plus 3y is equal to 9. So again, I'm going to go ahead and plug in 2 into the value of x. That gives me -6 times 2 plus 3y is equal to 9. -12 plus 3y is equal to 9. We're trying to solve for y, so we're going to add the 12 to the other side. We get 3y is equal to 21. And in order to solve for y, we're going to divide both sides by 3 and get y is equal to 7. So our answer, again, our answer has to be a coordinate. We're going to make that 2, 7. Awesome. All right, guys. Let's go to the last problem on this slide. So -7x minus 8y is equal to -15. -6x minus 7y is equal to -13. Once again, I have a problem where I can't just multiply the top equation or the bottom equation by something. I have to do it to both. So let's see, what should we cancel out? Should we do the x variable or the y variable? Let's do the x. Okay, so if we want to have the same value for the x but opposite signs, let's multiply the top by, let's do a -6, and then let's do the bottom by +7. Again, you're going to see why that's the case. The first equation, I am distributing the -6 to both sides, and that becomes 42x plus 48y is equal to 90. And then on the bottom equation, that's -42x minus 49y is equal to -91. Okay. Ooh, this is interesting. So let's see again, combine the like terms. So I'm going to go ahead and add these vertically. The x's cancel out. That was the intention. That's exactly what we want. And on the y's, when I plug that in, I'm going to have -y is equal to -1. So that means that y is equal to 1. And now in order to solve for the x, let's plug that into any of the equations. So I'll just plug it into the first. So I have negative 7x minus 8 times my y value equals negative 15. So I have negative 7x minus 8 equals negative 15. We're trying to solve for x here, so let's go ahead and add the 8 to the other side. Negative 7x is equal to negative 7. Divide both sides by negative 7. And we get that x is equal to 1. Awesome. So now our answer, I'll just kind of put it here on the left, is 1, 1. Okay, that's how you do substitution. That is one of the 3 methods that we use whenever we're trying to solve these systems of equations. So be aware that there's always different methods. Find whichever one you prefer, and then just run with it. Be bold when you're doing these types of problems. Okay, that is the first slide. Let's go to the second one. And the second one required us to do substitution. That is what the direction is asking. Let me go ahead and just kind of zoom in on that. Okay. And by the way, guys, if you're watching this on TikTok, you can go on my YouTube channel where you can see this live on a bigger screen. If you heard that, I'm just reminding the people that are watching on TikTok to go on YouTube, subscribe, and watch there. I feel like it's much, much better if you're watching it. You can actually chat. You can actually see this on a bigger screen. Anyway, back to the, let's do 63. So I have a problem. 6x minus 2y is equal to negative 6. Negative 6 plus y is equal to 5. So they want us to use substitution. Substitution is tricky. Some people don't like it. I personally think it's easier depending on the type of problem that we have. The goal here is to isolate one of the variables in one of the equations. So I'm going to take this second equation, negative x plus y is equal to 5, and I'm going to isolate the y variable. Let's add the x to the other side. And that's going to give us y is equal to x plus 5. That's exactly what you want. You want to isolate one of the variables, because now what you're going to do is you're going to take this entire equation and you're going to plug it in, aka substitute, in for the y variable in the first equation. So how would that look like? I'm going to have 6x minus 2 times, and this is where I plug in that x plus 5 into that equation. And now we're going to go ahead and start simplifying this, combining like terms and solving for x. So how are we going to do that? Let's distribute the negative 2 into everything. So we have 6x minus 2x minus 10 is equal to negative 6. That gives us 4x minus 10 is equal to negative 6. We're trying to solve for the x variable, so we'll add 10 to the other side, and we will get 4x is equal to 4, meaning that x is equal to 1. And this is just like the problems that we were doing when we had elimination in the previous slide. We found the value of x, so we're going to go ahead and plug that value into any one of the equations that we were given. And I'll just plug it into the second equation, just because it's much easier. So I have negative x plus y is equal to 5. That's the second equation that I was given in the original problem. And now I plug in 1 in for the x. So that's going to be negative 1 plus y is equal to 5. So negative 1 plus y is equal to 5. And if we're trying to solve for the y variable, let's go ahead and add 1 to the other side. And we get y is equal to 6. So we have our two answers there. X is equal to 1, y is equal to 6. So then our answer, I'll put it here on the top, is 1, 6. They always want your answer as a coordinate. Okay, so just keep that in mind. All right, let's go to the next one. We have 64. This is negative 2x plus 6y is equal to negative 6. X plus 6y is equal to 12. I know that we're tempted to use elimination, but the directions were asking us to do substitution. So in this particular problem, or in the previous problem, I isolated the y variable. In this case, I'm still going to work with the second equation that's on the bottom, but let's go ahead and isolate the x variable. So I have x plus 6y is equal to 12. And let's go ahead and subtract the 6y to the other side so that we get x is equal to 12 minus 6x. Well, minus 6y. Sorry. All right. And then now we're going to take this equation and substitute it, aka plug it in to the x variable in the first equation, the one that we were not working with originally. So let's see, I have -2, and this is where I substitute this value in. 12 minus 6y plus 6y is equal to -6. Okay, again, same method. I want to go ahead and distribute the -2 into the parentheses, isolate or combine like terms, and then solve for y. So let's go ahead and do -24 plus 12y plus 6y is equal to -6. That's -24 plus 18y is equal to -6. Let's add the 24 to the other side. And we get 18y is equal to 18. So y is equal to 1. Oh, so nice that we're getting some nice problems here. We don't want to have fractions. It's just a waste. Tedious is what it is. Okay, so we have y is equal to 1. How do we solve for the value of x? Which equation should we plug it into? Should we plug it into the first equation or the second equation? Let's plug it into the second equation. So this is my second equation. I'll write it in blue. I have x plus 6y is equal to 12. This was the second equation that I had in the original problem. So let's go ahead and plug in 1 for y. So that gives me x plus 6 times 1 is equal to 12. So that's x plus 6 is equal to 12. And if we subtract the 6 to the other side, then we are going to get that x is equal to 6. Awesome. And then now we have our answer. 6, 1. Be careful with this because we originally, I'll highlight this in the bottom. We solved, whoops, I said highlight. I'm scratching it off. We solved for y initially, and then we solved for the x. So we remember that when we write our answer, it has to be the x is first, which is 6, and then the y value is next, which is 1. All right, last problem on this slide, -5x plus 8y or plus 4y is equal to -6, and then I have y equals -4. This is actually one of the easier ones. We already have the value of y, which is really, really nice. So all we have to do is substitute, aka plug that in for the value of y in the first equation. So we're just going to plug it in there. So that gives me -5x plus 4 times -4 is equal to -6. So that's -5x minus 16 is equal to -6. Did I get that correctly? I did, didn't I? Ooh, this is the first time we're going to get a fraction as our answer. I can already see it. No, I lied. Not the case. Thinking too far ahead. That's what I get for not showing my work and try to think ahead already. So -5x minus 16 is equal to -6. We're going to add the 16 to both sides. That gives us -5x is equal to +10. And in order to solve for the x, we are going to go ahead and divide by -5, which gives us x equals -2. So that's kind of nice. We were given the y value. Now we need to find the x value, and that's going to be -2, 4. Awesome. All right. That finishes this slide. It looks like we have 3 more problems. But again, if you have any questions and if you're watching this live and if there's anything or some homework that you had difficulty with this week and you want to cover that, send it to theveganmathguy.com, or you could become a member by downloading my app and you can have a guarantee that I will solve those problems the next day. But in the meantime, honestly, if you want to support, follow me on Instagram, on TikTok, subscribe to my YouTube channel, and let's keep doing some math, baby. Okay, let's go to problem or slide number 3. It might be a little difficult for everyone to see, but again, there's people probably watching on TikTok right now. If you want to see this in full display, please go to my YouTube channel and watch it from there. Okay, so it says, Wilbur and Jasmine are selling pies for a school fundraiser. Customers can buy blueberry pies and blackberry pies. So I'm just going to go ahead and label them. X is equal to blueberry and Y is equal to blackberry. It's always good to just kind of give some variables for those things. And so let's talk about the first clue. They said that Wilbur sold 2 blueberry pies and 7 blackberry pies for a total of $145. This is a typical question that they like to give you when it comes to systems, and it's actually quite easy to set up. We know that you have 2 blueberry pies, 7 blackberry pies. That equation there can turn into 2x plus 7y, and that's equal to the cost, which is 145. Then we have the next situation. I'll highlight that in blue. Jasmine sold 6 blueberry pies and 2 blackberry pies for $112. What do you know? We can set that up as 6x plus 2y is equal to $112. And now they want to find the cost of each blueberry pie and blackberry pie. So really they're asking, solve the system, give me the value of x and the value of y. Doesn't tell me what method to use here, so I'm just going to go ahead and do elimination. Why not? So let's see. Let's eliminate the x's because I can already see that if I multiply the top equation by a -3, my x value will be -6x, and that's good with me. Okay, so what would that become? I have -6x plus or minus 21y is equal to, I have to do some math here, -435. And now the second equation, nothing changes. 6x plus 2y is equal to 112. And just like we did with elimination in the previous slides, we're just going to go ahead and combine the like terms. Add vertically, the x's cancel out because -6x plus 6x is equal to 0. And then we have the next one, -21y plus 2y is -19y. And now we have to combine and add the right side, -435 plus 112, that's -323. And I have one last step to do. Divide both sides by -19. And guys, we have y is equal to 17. Now keep in mind, y is equal to 17. That's technically going to be the price of each blackberry pie. Now we just need to find the price for the blueberry pie. How do we do that? Go ahead and plug in the 17 into any of the equations that we have. So I'm just going to plug it into the first equation. I'll highlight that. I'm going to plug it into that equation that I highlighted in green. Do I have enough space? I just might, but maybe what I can do is I'll make this a little small. Whoop, don't want to annotate like that. Let's just make this smaller and then move it off to the side. Gotta love the power of Zoom. Okay, so y is equal to 17. Let's plug it into the second equation. The second equation that I had was 2x plus 7y is equal to 145. So now I go ahead and plug in the y, which is the price of blackberry pies, and that's going to be 17, is equal to 145. So I have 2x plus 119 is equal to 145. And if you're wondering how I'm multiplying these so quickly, 7 times 17, I'm using a calculator. I'm no genius. I am not very smart. So, I mean, I'm just using a calculator. It's just what it is. Okay. I subtracted the 119 to the other side. I got kind of sidetracked there, but that's how we got 2x is equal to 26. And now all we have to do is divide both sides by 2, and we get that x is equal to 13. Now, if you write your answer, x is equal to 13, y is equal to 17, I think that's fine. Some teachers are going to be really picky and they're going to say, okay, well, what do you mean? What units? What is this? So we're just going to say We're going to write it as blueberry. We're going to say is $13. So I'm actually going to use units. And then blackberry is going to be $17. Man, I don't know. Expensive pies? What do you think? $13 and $17? I don't think that's too bad. I mean, blackberry pies, that shouldn't be that bad. By the way, I live in Washington right now. The blackberries are out. They are thriving. So if you go anywhere around Washington and you see blackberries, you got to pick those up. Oh my goodness. Forage them, eat them, make some pies. Yummy. Super, super yummy. All right. Now we're down to our last slide. Again, if you're watching this live or if you're watching this later on and I'm not live, please feel free to send your questions to theveganmathguy.com, where we try to solve as many homework problems as we possibly can. I am here for you. I am going live on YouTube every single weekday to cover as many math problems as we can. That's what we do. We're going to improve our math survival skills this year. I know it. I believe in you. Let's do it together. All right, let's go to the last slide here, which for whatever reason wasn't working. Now I'm back. Let's go ahead and zoom in on this slide there. Okay. I like this particular problem. If you are in an algebra class, like in middle school, this next problem, something that you don't quite see as often, though this was sent to me by a middle school student. But again, not a typical problem that you will see in class. So I wouldn't worry too much about it yet. If you're in algebra 2 or if you're in high school algebra, be prepared because these will occur and you will see problems like this. So let's just go ahead and read that carefully. A boat is traveling at 120 miles each way downstream and back. The trip downstream took 3 hours and the trip back took 6 hours. What is the speed of the boat in still water? And then what is the speed of the current? These are typical questions when it comes to speed. They talk about, you're traveling along the water or you're even flying on a plane with a tailwind or a headwind. The equation that we should always keep in mind when it comes to problems like this is that distance is equal to speed times the time. So let's talk about the first scenario. Let me go ahead and highlight that in green. Well, you're traveling 120 miles. So they're saying the trip downstream took 3 hours. Okay, the trip downstream. If you're going downstream, think about it. Are you traveling with the current or are you traveling against it? You're going downstream. So whenever they're talking about downstream, you're going with the current. So downstream with current. And what that means is that whatever speed you're traveling, whatever speed your boat is going, the current is adding to that speed. So you're actually going to be going a little faster. And of course, when you're going downstream, you're going against the current. So you're going with the speed of your boat and then you're subtracting the current. Let me show you what I mean by that. So the first equation, they're saying that the distance is 120 miles. We already know that's the case. Let me put that down. Yeah, I'll just put it up here. 120 is equal to, now here's the thing, X will make that equal to your boat speed. And then we're going to add that to the current because you're going with the current. And that took me 3 hours. So what I did here, this was my distance. This is the tricky part. Understanding that the current and the speed of your boat was your total speed. And we're going to have our time. Okay, so one thing I didn't do is include that X is equal to your boat speed. And then Y is equal to your current. Okay, so just keep that in mind. All right, let me erase some of the labels here. This is our first equation. And now let's talk about the second equation. The second equation, they're saying that the trip back took 6 hours. No surprise there because you're pushing up against the current. So the current's kind of holding you back. It's going to take you more time to travel this 120 miles. So upstream, we're going to write is against current. Now, how is that equation going to look? Well, how much distance did you travel? The same thing, 120. Now you have your current or the boat speed minus the current of the water because it's pushing you. And that took you how much time? 6 hours. Okay, so here's what we're going to do. This looks a little funky. And again, I told you, if you're taking middle school math, you probably won't see this. High school math, you'll for sure see problems like this. So for each step, I'm just going to distribute the 3 to both variables. And in the second equation, let's go ahead and distribute the 6. So that's going to give us 120 is equal to 3x plus 3y, and 120 is equal to 6x minus 6y. And what are we going to use? I would suggest elimination. We could use substitution. Nothing wrong with that. But I'm just going to use elimination. So let's see. I see my y's already have the opposite signs. So what I would do is I multiply the top equation by a positive 2. Now, what is that going to give me? Let's go ahead and move this down here on the bottom so that we can kind of, have a good flow going. And that's going to give me 240 is equal to 6x plus 6y. And I have the second equation, which is 120 is equal to 6x minus 6y. And let's go ahead and combine that vertically. And that will give us 360 is equal to 12x, and then the y's cancel out. And in order to solve for the x, let's divide both sides by 12, and that we get x is equal to 30. Awesome. Okay, we get x is equal to 30. That is the current, the speed of the boat. And this is going to be miles per hour. Why miles per hour? If you look at the problem itself, you're traveling 120 miles in 3 hours or 6 hours. So it's going to be miles per hour. And so now we know the value of x. Let's go ahead and figure that out. Use that to figure out the value of y, which is the current of the water or the speed of the water. Let's plug it into either equation. I'm just going to plug it into the first equation. So I have 120. Whoops, let's continue using the green since the first equation is green. 120 is equal to, and now we have our 30 for our x plus y times 3. We can go ahead and do a few things. Let's just distribute the 3. So 120 is equal to 90 plus 3y. I really want to make sure we get this entire problem in this little space that I have. So let me subtract the 90 to the other side. It might look a little small, but we get 30 is equal to 3y, and then divide both sides by 3. Ooh, hope it fits. It does. I think it's going to fit. Everyone, y is equal to 10. Whoops, I did it in blue. Let me continue doing it in green. Y is equal to 10. Okay, so in this case, they didn't really want a specific coordinate. They just want to know what is the speed of the water, which is 30, or the speed of the boat, which is 30 miles per hour. And then what is the speed of the current? I noticed that I just put 10, but it should be 10 miles per hour. So make sure you label. Some teachers get really picky about that. All right, guys, so let's go ahead and do number 68. We have the last problem here. 68. I just want to say what a joy it's been. I know it's Friday. Not many people are going to be posting or sending me problems, which is fine. But again, if you're watching this and it's the weekend, it's the weekday, send me your problems. You can go to the veganmathguide.com. There's technically a link in the description below. There is my website on the bottom of the screen, the veganmathguide.com. Send me whatever questions you have, and we'll cover them together. Again, I want you to thrive this school year, and I'm here for it. Okay, back to number 68. So Jenny's school is selling tickets to a choral performance. On the first day ticket sales, the school sold 7 senior tickets and 3 student tickets for a total of $118. If you recall, this looks very much like the blueberry and blackberry problem. And then the next one is the school took in $93 in the second day by selling 3 senior citizen tickets and 6 student tickets. Find the price of senior citizen tickets and the price of student tickets. Well, Let's label this. Since they started with senior citizen, I'm going to make that my X. So X is senior. And let's make our Y student. And let's see. Let's talk about the first clue. They're saying on the first day, they sold 7 senior and 3 student for a total of $118. So that equation will become 7x plus 3y is equal to 118. The next clue is on the second day, they made $93 and they sold 3 senior and 6 student. So that will be 3x plus 6y is equal to 93. And now we have our system. We have 2 equations involving x and y. We want to solve for one of the variables. We want to cancel out one of the variables there. Let's see. You know, I'm looking at that second, the y in general. And one's a 3y, the other one's a 6y. So I think if I just multiply the top by a -2, I think that'll really help me. I put a +2 there, so let me change that by a -2. Okay, so what's going to become of this? We're going to have -14x minus 6y is equal to -236. And then on the bottom, I still have the 3x plus 6y is equal to 93. Beautiful. Check that out. We have -6x or -6y, and then we have the +6y. So let's go ahead and combine that vertically. And what do we have? -11x is equal to -143. And now in order to solve for x, we're going to divide both sides by 11 or -11 and get that x is equal to, I think this is 13. X is equal to 13. Perfect. So keep in mind, this is senior citizens is 13. They're asking for the price, so this will be $13. And we'll write that as our answer at the very end. So we have the value of x. How do we find the value of y? Plug it into any of the equations versus whether you want the first one or the second one, totally up to you. No reason for choosing this one, but I just want the second equation. So 3x plus 6y is equal to 93. This is where I plug in the 13 into my equation. So I have 13 times, or 3 times 13, sorry about that, plus 6y is equal to 93. Let's go ahead and simplify. So we have 39 plus 6y is equal to 93. We can subtract the 39 to both sides, and we get 6y is equal to 93 minus 39, 54. Nice. And now all we need to do is divide both sides by 6, and we get that y is equal to 9. Okay, so at the very end, we just say, because they were asking us for the tickets, we have 13, or we say senior. Whoops. Yeah, come on, I got to do better than that. Senior is $13, and then we'll say student is $9. Nice. Okay, was this fair? $13 for senior and $9 for students? I don't know. You decide. All right, guys, this is it. Those were all the problems I had. I hope you had a good time. If you have any questions, you're more than welcome to, again, follow me on Instagram, follow me on TikTok, subscribe to this YouTube channel, comment on this video, and let me know what you want me to review next. And if you have any homework questions that you really want to review together, let me know. So go to theveganmathguy.com and submit your questions, or become a member by using my app, whatever you want to do. All right, everyone. In the meantime, this is it. I hope you have a great weekend. The sun's still coming out here, which is really nice. We're going to enjoy the last few days of sunshine that we have until fall comes around, and hopefully do some hiking. But let me know what you do on the weekend. Let me know what you want me to review next. Until then, happy trails.